Welcome! We're going to do a walkthrough on the LMS for STEM with Computer Science 1 through 4. The educational technology is a key feature of our programs. The learning management system includes all of the following that aims to benefit self-directed learning, monitoring of students' progress, and to cultivate mental cognition. Once you have logged into the account, you will be brought to the CMA LMS homepage. This is the welcoming interface when teachers are logged in. You can see notifications, recent activity, and upcoming events too. With a teacher's account, it allows you to switch to the students page. Teachers can view the courses that they have access to. On the STEM CS Level 1 course, you will see groups, members, attendance, badges, and a list of modules. But today's demo, we will only present Module 7. Here is a progression chart for STEM with Computer Science Level 1 course. Starting with an orientation to the computer and its parts and functions, students will advance to learn how to use the computer's interface, to draw and to type using age-appropriate applications. For today's demo, I will show you the content for students and resources available for teachers from Module 7, Better Animation, and Module 9, Files and Folders. We progress from students' existing knowledge on using Paint tool and connect them to Scratch. We build the 7-year-old's learner's mouse and typing skills. Of course, most importantly is to register computational thinking into the learner's cognition. You can see this in modules 5 through 7 and 12 through 16. Each course begins with sections of 2 types of assessment. Here, I would like to highlight on one of our program's differentiator, which is authentic assessment, where students are assessed on both formative and summative assessment. Rubrics are used to systematically and fairly grade the projects. On CMA LMS, we have installed an easy-to-use rubric marking function to make your assessment process more efficient and effective. Moving on, we will take a look at navigating lessons on LMS. This is a module for the beginners. STEM with Computer Science 1, Module 7 on Better Animations. There is a brief description of the module content as well as the list of topics that will be covered. Here, we have teachers and students materials for the module. Labels with students are for students. Students' classroom materials are content that teachers will cover during the face-to-face lessons. Student self-learning materials are guided activity for students' own exploration. This contributes to another 32 hours of self-learning credit hours. Face-to-face class time is 32 hours, so altogether we have 64 hours of lesson per level. Each module can stretch up to 3 lessons, which makes up to 32 hours of face-to-face. I'm sure that you, as today's educators, would agree that this blended learning approach helps to eventually develop students to be independent learners. The label with teacher is the lesson plan for teachers to use to deliver the content in class. This is only visible to teachers. Better Animations is a sample module of using Scratch. Students are guided to build a program and then asked to remix the program. Our lessons are designed to reflect the learning by doing approach. As mentioned, in class, the students are guided by the teachers, but at the same time are allowed to explore the tools. At the end of the guide, the students are asked to remix the program. This is to encourage the development of one of the life skills, creativity and innovation to be a creator. In self-learning materials, the students are encouraged to self-discover new learning and solutions. This activity reflects one of our key pedagogy, learning by doing, where students are exposed to learn new skills and knowledge by doing the activity. One of the most commonly asked questions is if there are any ICT basic computer skills in the curriculum. The answer is yes, enhanced or improved ones. This is a sample lesson of our program covering ICT types of lessons too. There are lessons featuring elements of ICT or basic computer skills such as the internet and the impact of computing. Here in Module 9, files and folders aim to develop students into becoming not just a computer user, but an efficient computer user. Navigating through the courses and modules can be easily done on the left panel. In STEM with Computer and Science Level 2, we introduce intermediate programming with Scratch. We also cover digital literacy in modules 2 to 3, 5 to 6, and 10. This is in line with Computer Science Teachers Association standards, where computers and communication devices are covered in any computer science curriculum. In STEM with Computer Science Level 2, Module 4 covers key topics on digital citizenship or elements of cybersecurity. In the module, students will practice ways to prevent cyberbullying and discuss ways on protecting their information online. The module on cybersecurity also aims to develop students' understanding of how to protect their computers. Hence, the topic on viruses is covered for students' basic awareness. A teacher may view the CMA LMS as a student. You can see that the teacher materials are not in blue. It means that it is only for a teacher's view and students are not able to access teacher's materials. This is the Teacher's Notes section, where detailed guide with steps or suggestions listed in each topic. On CMA LMS, these are slides which can be used to complement the Teacher's Notes for clearer illustration. Moving on to Module 7 on debugging. What is debugging? It is a programming term which means to debug a program. It is a process of finding and resolving defects that prevent the program from working properly. This is a module reflecting the practice of computational thinking concepts. As students build up their Scratch programs, they are introduced to shortcomings and problems in programs with bugs and procedures for correcting those problems. Students will be guided to find solutions using computational thinking concepts such as decomposition, algorithms, patterns, abstractions, logical reasoning. Of course, these concepts will not be explicitly taught by itself. These concepts, together with several other pedagogy approaches, will be part of the teacher training. In STEM with Computer Science Level 3, the main purpose in this level is to get students to learn Scratch as a communication tool. Students will use Scratch to create animations, explaining knowledge from other classes, such as from science class. Students will be building projects using their programming skills learned in STEM with Computer Science Level 1 and 2. At this level, progressing from Level 1 and 2, you should be able to see how our lessons are designed reflecting the spiral model of the curriculum. After students have coded the example water cycle quiz, they are ready to join teams to plan in creating their own interactive quizzes. Research and planning is only part of the task in the project-based activity. You may click on teachers' planning materials to show planning tools for their project or just point. Students begin to work in teams actively to create their own programs. Student group schedules, conduct research, plan, program, and refine with an iterative design. Student groups also use Gantt charts, storyboards, design charts, and other materials to foster successful development processes. In this level, most of the module activities are based on mathematics skills, such as the concept of probability in Module 7 and 8. Eventually, they will learn that Scratch can be one of the computational tools, which means that it can be programmed to do calculations to solve mathematical problems. Using more tools from Scratch 2.0, featuring customizing their own blocks, it empowers them to think more abstractly, which is one of the big ideas behind this program, incorporating computational thinking and logic essence. What does it mean by abstraction? For example, in this module, teacher will guide students in playing a game of finding the largest number physically. Pick 3 students and ask 2 students to pick the number between 0 to 30 turn by turn for 5 times each. And the third student will need to identify the largest number that was said as soon as the 10 numbers were said. Now, students will need to program the game using Scratch. In each curriculum year, students are required to produce their yearly project. Add STEM with CS1, Virtual Fish Tank. Add STEM with CS2, Dance Party. Add STEM with CS3, Create a Quiz. Add STEM with CS4, Create a Survey. At the end of the year project, students are required to present their projects and findings. This is an activity that helps to conclude a holistic development of a critical thinker, a collaborator, and a creator, which we highly emphasize in our STEM programs. The project allows students to apply their knowledge and skills learned for the year into real-world practices. Are our activities done in Scratch? No. As you can see on this page, we have unplugged activities. In between lessons, we have unplugged activities that introduces students to computational thinking through concepts such as data compression and algorithm, separated from the distractions and technical details of having to use computers. No programming is required to engage with these ideas. Our program uses Scratch as a fun tool. More importantly, it is emphasizing on the thinking skills which we aim to transfer to the students through your trained STEM teachers. Welcome! We're going to do a walkthrough on the LMS for STEM with Computer Science 1 through 4. This catch-up unit of the curriculum is designed to familiarize novel students with digital tools for productivity and block-based programming Scratch. It is a mix of CS1, 2, and 3 modules, and accelerated guidance for students through 1 to 8, and then students work in teams for the last 3 projects. Welcome! We're going to do a walkthrough on the curriculum STEM with Computer Science 5 to 6 on the LMS. For STEM CS 5 and 6, the tools we are using in the curriculum is called SemBlocks. Level 5 introduces students to SemBlocks, a new programming language designed for students who have never programmed before or only have experience with visual programming. As mentioned, SemBlocks starts with friendly drag and drop code blocks, which allow students to begin programming without fear of failure. In STEM with Computing 5, students review many of the programming concepts that were introduced in STEM with Computer Science Level 1 through 4. The beginning ideas in computer science curriculum expose the students to the power of computer science and how it can be used to impact their lives. Digital citizenship is one of our curriculum STEM with CS Big Ideas, with an objective to create adequate awareness, especially when using the internet. Activities in Level 5 then challenge students to move beyond identifying the structure of programming concepts. It gets them to understand the function of how programming concepts, which can be applied with computational thinking. Here, you can see how students follow the lesson plan with animated illustrations. Teachers' role is to guide the students and go through the programming using these materials. The work to put all CS programs into similar outlook to CS5 is in progress. Deepen computational thinking skills. In Level 6, students will learn about the fundamentals of computational thinking and how they can be applied when creating a computational artifact. Students will also be introduced to the software development process as they learn how to work collaboratively and incorporate feedback into the creation of computational artifacts. Students will additionally learn more about algorithms as they create lists in SemBlocks and discover new insights into mathematical challenges. Level 6 also transitions students from block-based programming to creating computational artifacts with JavaScript. As a result, students will see the power of text-based programming and its applications in their everyday lives. Level 6 also continues the exploration into object-oriented programming, as students learn how OOP allows them to make even more powerful computational artifacts.